Hey buddies, how are you all? Welcome to Brahma Writings. Today I am here to discuss about the difference between cache and persist. These are two important performance tuning techniques in Big Data Spark. Before getting into the topic, I just wanna introduce some basics first. So in Spark, there are three abstractions or APIs that we regularly use to create the data frames or resilient distributed datasets from data. So these are the abstractions. Most of the projects are now using DataFrame. When it comes to memory, right, there are two options. The first one is disk, and the second one is in memory. So when we talk about Spark cluster will be having multiple number of worker nodes. Every worker node will be having or will get allocated with some space and RAM in memory. So whenever you create one RDD or DF, right, if you make use of cache or persist, the data will resides in memory. That helps Spark applications to run faster. So that data is readily available in memory so that it won't request network operations with external memories or hard disk to get the data and run it. Since the data is readily available in memory, it takes very less time when it compared with to get the data from uh, network disk or hard disk and run the application. So the target is to improve the performance of Spark job, right? So these two options will definitely help Spark job to run better. So when it comes to cache, we have only one option where the DF data frame or RDD will store within in memory only. Okay, but when it comes to persist, we have multiple options where we can make use of these options to use in memory and disk. We can place the data in memory, or we can make use of both memory and disk. You can also make use of only memory only with serialized data objects. This concept serialized data object, I will record a separate video for that. And you can also make use of memory and disk with serialized data object, and there is one more option, disk only option. So these are the two important performance tuning techniques which helps Spark job to run faster. So when to source cache and when to source persist. If you want a simple and memory efficient caching strategy, you can use cache. If you need more control, like if you want to put some data in disk, if you want to place this data in memory, or if you want to utilize both to store the data, here you have multiple options, or you will be having control over the storage level. You can choose whatever you want based on the requirement. So let me get into the code and explain you. So I'm making use of Databricks. Oh, cluster got terminated. Even if I try to create new one, it will definitely take time. Let me try to make use of Google Colab. If you are using Google Colab first time and trying to execute PySpark code, right, you need to make sure you start with this command because you first need to install PySpark. Okay. Once you are done with that, you can proceed with importing Spark session. Google Colab is cloud-based IDE. It really works good for you. So here is my data. I have columns also. Now using this, I'm creating data frame here using the function create data frame. So let me create data frame. data frame is created successfully. Now let me show you the data. If you wanna see only 3 records, you can also get the required number of records like this. And now if we go further, this is nothing but I'm just adding some print command. Now here is the command that we need to discuss. So now let me execute df.cache. So if I execute df.cache, this particular data frame will be cached and stored in memory of this worker node. Wherever I execute the Spark, wherever I use a Spark cluster, right, that particular Spark cluster will be having multiple worker nodes. And if you use df.cache, it will store this entire data frame in that worker nodes internal memory, in memory, that we call it as RAM. Now I'm performing one action on the created data frame. So here I'm trying to see the execution plan, how it is getting executed, from where it is getting the data, from where it is scanning the data. Okay, this particular execution plan will give us some steps how it is getting executed. Okay, so here, from here also, if you are really using some cluster, Spark cluster, you can see some different values here. Now I'm trying to import storage level, because for Persist we can make use of disk only, memory and disk, and there are many options, right? So in order to make use of those options, we need to import storage level first. Now here is the command that I am executing now, df.persist. So here I am only taking disk only. So whenever I execute this particular command, the entire data frames data will be stored in disk only. So here I am not selecting in memory or anything else. Here I am only selecting disk only. So on this one also I am performing one of the action, and let me show you how this is getting executed here. This is the execution. So this is another command that you need to remember whenever at the end of every Spark job, right? If you make use of persist, you can unpersist it to clear the space actually for the next job. So I have cleared the space using unpersist. Now using Spark.stop, you can stop the Spark session. So hope you got it. Using cache and persist, these are the two important performance tuning techniques to improve the overall Spark job.